So today we're going to learn about a dilation and why are dilations different than all of the other three that we've talked about so far. Paul?
Okay, so with the other stuff we've been talking about, we've been moving it. With dilations, you either make it bigger or smaller. You're changing the size.
Correct. We're changing the size. So if you remember from the very first day, what word means they don't change size? There was a vocab word we learned. No, dilations do change size. What's the one word that means it does not change size?
Non-dilation.
Starts with an R. I-G. Rigid. They are rigid if they do not change size. So, today, we're going to learn about a dilation, the one that does change size, okay? Now, you'll want to write this down on your piece of paper somewhere, and K, this new value K, we call it the scale factor. K is the scale factor, and the way we find K is we take the image and we divide it by the pre-image.
It's not on.
How do I know which one is the image and which one is the pre-image? Yeah, the prime. So in this picture, which one's the image, blue or red?
Blue.
Red is the image. It's the one that comes second. It's the one with the primes. The pre-image is the original, right? The one that came first, that would be blue. So let's say that the P prime Q prime is 9 and PQ is 3. And I wanted to find the scale factor. What am I going to put on top? Which one's the image? 9 divided by the pre-image, the original is 3. Therefore, what's my scale factor? 3. Now, what is a factor? What does it mean to be a factor? Paul?
You're a multiple of number.
Yeah, so if I asked you what are some factors of 10, what would you say?
2 and
2 and 5. That's because 2 times 5 is 10. Factors are things that we multiply together. So it makes sense that we call this a scale factor because it's what we need to multiply the pre-image by to get the image. Okay? So we'll do some practice of these here in just a second. So let's take a look at this example right here. You have on your notes. And you might want to, it's kind of hard to see, so I'd mark this. This one here on the left is P prime. And on the example B, the one in the middle is P prime. It's kind of blurry, not a very good picture. So I would write that in. So let's focus on A first. We're going to look at this one first. And we're going to come up with the scale factor of the dilation, okay? So what is C? What is the distance from C to P prime? That's the image. C to P prime is 10. So that would be 10 over. We always take the prime and we divide it by the original, the not prime. So how far is it from C to P? 6. 10 over 6. So image divided by pre-image. And then always reduce. So what does 6 over 10 reduce to?
5 over 4.
5 over 3. 6 divided by 2 is 3. Now, in this picture, did it get bigger or did it get smaller? So we start with P, C to P, right? And then we moved from C to P prime. So what did we do? We got bigger. We have a new word today. It's called an enlargement. So there's two types of dilations. The first one is called an enlargement, if you get bigger. Alrighty, now let's do example B. So how far is it from C to P prime?
22.
C to P prime is 11. Divided by, how far is it from C to P? 22. You always do prime on top. Just remember that, prime on top. And then go ahead and reduce that. 11 over 22 is? 1/2. So in this case, if we started at P and then we went down to P prime, what happened? We got smaller. We call this a reduction. If it gets smaller, it's called a reduction. Now, the way you find this out, if the scale factor is greater than 1, go ahead and write that in. If the scale factor is greater than 1, it's going to be an enlargement. And that makes sense, because what happens if you multiply a number by 2, or you multiply a number by 10? What's going to happen to it? It's going to get bigger. What if you multiply something by a number that is less than 1? So let's say I have the number 10, and I multiply it by a half. What do I get? Half of 10, which is 5. It got smaller. Okay? What happens if you multiply a number by 1? It stays the same. So is that a dilation if it stays the same size? No. That's why there's no or equal to 1. It's either bigger than 1 or it's littler than 1. So bigger than 1 is an enlargement. Smaller than 1 is a reduction. Okay? So now, go ahead and do this example on your own. I want you to come up with the scale factor. So find K, and then tell me if it's an enlargement or if it's a reduction. Okay, what number goes on top?
1.
Nope. 4. Prime on top. 4 over 20 is what you should have written. Prime on top. Got to remember that. Prime on top. 4 over 20. And then go ahead and reduce that. 4 divided by 4 is 1. 20 divided by 4 is 5. That is your scale factor. And is that greater than 1 or is it less than 1? So it is a reduction. All right, now's the fun part. I love doing these. The first thing you're going to do, you're going to take your straight edge, and we're going to make something that I like to call the tracks. So we're going to take, you're at point P, and I want you to draw a line that goes through and past the corner or point X of the rectangle. So point P is called the center of dilation. Point P is called the center of dilation. Kind of like we have a center of rotation. That's the point that we rotate around. Dilations have a center of dilation, and basically that's the point that you're getting bigger from or you're getting smaller to. So you'll see what I mean by that here in a second. Okay, now I want you to take your straight edge. Once again, start at point P, but I want you to go, this time through W. So start at point P, but this time go through vertex or corner W of the rectangle. So it looks something like this. And then you're going to do the exact same thing for Y and Z. So you're going to have 4 of these so-called tracks. So start at P and go through corner Z. And start at P and go through Y. We need to know the scale factor, and they tell us the scale factor is 2. So are we going to be getting larger or smaller here? 2 is larger than 1, so our shape is going to get larger here. So follow along with me. Now this works really well with centimeters. So on your protractor, on the top of it, you have centimeters. What I want you to do is I want you to measure the distance from X to P. How many? And it comes out nice and pretty with centimeters. How far is it from X to corner, or from point P to corner X? How many centimeters at the top of your ruler? It should be exactly 1.5 centimeters. You guys see that? So from here to here is 1.5 centimeters. So if our scale factor is 2, remember the scale factor is the multiplier. So if we want to go twice the size, what's 1.5 times 2? 3. So now what you're going to do, start at point P, and you're going to measure 3 centimeters down the track, and that's where you're going to put x prime. Now, if x is 1.5 centimeters away from P, what else is going to be 1.5? Z, right? Because it's the same side of the rectangle. So Z is 1.5. We're also going to double that. So start at P and measure 3 centimeters down the road, and then we're going to call that point Z prime. Now for W and Y, we need to remeasure, because those are on the other side of the rectangle. So go ahead and measure with centimeters. How far is it from P, the center of dilation, to W? Yeah, it should come out nice and pretty. It should be exactly 2 centimeters. So how far down the track are we going to go if we're doubling it? 4. So now start at point P, and if this is 2, we're going to move W 4 centimeters down the track. And we're going to call that W prime. So go ahead and place Y also 4 centimeters down the track. About here. And what's going to happen when we connect our 4 points? Yay! Okay, now real quick, what if the scale factor wasn't 2? What if it was 1/2? Are we getting larger or smaller? It's a reduction, right? So what would I do to the measurements if the scale factor is 1/2, Olivia? Yeah, multiply it by 1/2, also known as dividing by 2. So if it was 4 centimeters away, how far away from P am I going to move it? Only 2 centimeters away. So if you do half the distance, half the distance, half the distance, and half the distance, what's going to happen? A little baby rectangle. That's a reduction. You just do it the other way. You just do half the distance, or a third of the distance, or whatever the scale factor may be. Go ahead and look at your cheat sheet, and at the very bottom you should see this. This is our rule for a dilation. This is our rule. And what is K? What is K called? Scale factor, and that's what you multiply the pre-image by so you get the image. Okay? So go ahead and flip to your graph. And let's write down these 3 points. So 1, 1, 2, 3, 4, 1, and then go ahead and plot those on your graph. So what does your cheat sheet tell you to do to the x and the y values? Down at the bottom it says xy needs to turn into what? K times x and k times y. So on this example, our scale factor is 3. That's k. So what we're going to do, we're going to take all 3 points, and we're just going to multiply them by k, which is 3. So if you take the point 1, 1, and you multiply both those by 3, what are you going to get? 3, 3. If you take 2 and multiply it by 3, what are you going to get? 6, and 3 times 3 is 9. 4 times 3 is 12, and 1 times 3 is 3. So you literally just multiply everything by 3. This is super easy. And now 12 is going to be a little bit off the graph. That's okay. But go ahead and plot your new triangle. So that means everything about your triangle should now be 3 times the size. So how wide is it, or what's the base of this triangle? How long is it? 3, right? So now count the base of this triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So everything about the triangle is now 3 times larger, even the sides. Now what was the center of dilation here? It is the origin. Now look at your cheat sheet. It says at the top, rotations with respect to the origin. So this little cheat sheet only works if you're dilating from the origin. So the way you can see this, if you start at the origin and then you draw a line through the bottom right vertex and the bottom right vertex, they should all connect. And then if you draw a line from the bottom left vertex to the bottom left vertex, they connect. And then the top to the top, can you see how it all kind of spawns from the origin? You're going to have to find the center of dilation, and it's not going to be 0. So what you're going to do, you're going to take your ruler, and you're going to connect vertex to corresponding vertex. But you're going to just kind of keep going for a ways. And then you're going to connect vertex to corresponding vertex. And then vertex to corresponding vertex. And what's going to happen?
They're going to meet.
They should all meet somewhere, right? So that is the center of dilation. So what is the center of this dilation?